We are now going to listen to Vitaly Davidoff about AI-based API protection. Thank you.
Yes, it's okay? Okay, great, thanks. So thank you very much for joining my session today. And before we dive deeper, I want to introduce myself. My name is Vitaly Davidoff. I'm application security lead at JFrog. I used to be developer for many years, moved to the security team about 7, 8 years ago. It's my second time on the DeepSec, and I'm very happy and proud to be here, and thank you for organizers of this conference. Even we have COVID situation, we're still here and can share our knowledge, so it's great. What I'm going to talk about today is all this session based on our research was done for investigate API security solutions, AI-based API security solutions. So I'm going to be as much vendors neutral as possible, so don't want to name vendors. I have only one slide at the end of my presentation, some kind of the overview of the startups in this area, but I will try to be the, not to name the tools and vendors in this presentation. So I'm going to provide just a brief overview of what is API and why it's so important, what attacks we have on API, and actually why classical or traditional based solutions cannot help us. They can, but not 100%. And we will talk also about the capabilities or AI-based capabilities we want to have as part of the API protection tools if we want to choose one. So let's get started. APIs, I don't need, I think, to explain what is API. It surrounded us. We are using it all the time. Once we want to, so when we're using Google, Facebook, etc. So we're using APIs all the time. But the general, on the general explanation about the APIs is kind of the definition and protocols we can use in order to communicate with our service provider. So we defined a contract, as you wish, to what service provider expect from the service consumer to receive, and what the data will be provided back to the service consumer. So it's in general, okay, it's kind of the big, representation of the APIs, and it's not something new. Okay, if we can see the API protocols evolution, it's more than 20 years for now. We can split all the protocols we have by two main parts. Some kind of the technology-centric solutions like Corba, DCOM, COM, RMI solutions, RMI interfaces, and the HTTP-based or textual representation of the protocols or the APIs, like SOAP, REST APIs. I'm going to talk mostly about the REST API because it's kind of de facto the winner for now and widely used. But there are others. And the text-based, meaning that we define our contract in some kind of text representation. It might be XML, it may be JSON, whatever. And then we are not related to specific technology, Java or .NET, in order to communicate each other services. And then we can take it further and can kind of define it three type of the APIs in general. Again, we have public and internal. It's straightforward. Public APIs, anyone can call public APIs. They are available by internet. Do we have authentication? Don't have authentication? It doesn't matter. But those APIs are available. Okay, endpoints available. Internal, it's something they're using inside our realm. It might be service-to-service communication inside the Kubernetes cluster, for example, or some kind of the internal calls between our services, but inside our networking, for example. And they have something between, we have partners or B2B. Those APIs are mostly used for our vendors or partners to connect our endpoints. It's kind of the more restricted. They are available by internet, but maybe we can only consume them by VPN tunneling, for example, or some IP whitelisted listening. So it's kind of the more restricted APIs. Okay, about the trend, I'm sorry, but these numbers are not not actual, because as you know, last year we saw the spike of API usages in all the areas, and for now I think it's going to be about 90% in general. All the services using APIs, any kind of APIs, the SOAP, REST, whatever, but it's just because the COVID situation, a lot of services moved to be digital consumed now, and we have the spike of the usage and the new APIs introduced. And once it's so popular, it's also popular from the attacker perspective, because what the main idea of API? To communicate and provide the data. Okay, so we're sending data, we're receiving data. So that's the very good, the backdoor or attack vector to get and put attacker's hand on our resources, on our data. And you can see just an example of the T-Mobile or the Google Plus. We will talk about it a little on the next slide. Salesforce, the very famous, hacking on the Starbucks. It's not real hacking, it's not the breach behind this. If you know about the Starbucks, it's very interesting. It's 1 year ago, but it's just the perfect example of how attackers tricked WAF, Web Application Firewall, in order to get the data from the Starbucks. It was the ethical hackers, so it's not breach from this issue, but it's also showing us how can we manipulate attributes and access control in order to get data from using API. And it's also very important to understand that we saw more and more attackers using AI-based solutions to approach APIs. So that's a very interesting point, just to keep it for the later discussion. So they're using AI, they build some kind of fuzzing solutions to understand how API works, etc. And it's very hard to catch AI-based attacks. So then, how can we protect? And so the OWASP, I think I don't need to explain what is OWASP. OWASP is the Open Web Application Security Projects. It's kind of the organization to provide a lot of resources about how can we protect our web resources. If you are not aware of OWASP, you're just welcome to find it on the Google and see what they have. But it's the famous project on the OWASP is the OWASP Top 10 Web Application Security Risk. And they thought to add the new bullet for their API security protection, for API security risk. They very soon they recognize that it's not only one. We have a lot of API security-based risks in general, so we need to create the separate list, like they did for mobile application, for example. And they created, in 2017, they created the API Security Top 10 list. As you can see here on the left side, the most important things here is the broken object-level authorization and lack of resources and rate limiting, mass assignment, etc. So I'm going to show the example and see how the AI-based solutions can help us to protect against these risks. So I can split all the attacks and all the risk on the problem for API security by two main parts. Part number one is the most well-known, SQL injection, XSS, etc., DDoS protections. So it's something we know, and something new, something unique for APIs like business logic, access control logic, etc. So it's much critical for APIs. Let's just discuss a little bit about the most critical. So the first one is the role-based access control problems or attribute-based access control problems. There are kind of how can I trick my business logic, my API business logic to do something that is not allowed to do. So for example, yes, I have the token on my request, but I also can play this attribute like account ID, user ID, etc., in order to get information for someone else, for example. Some separate, different account, for example, it's not mine account. And the business logic is something very, very related to the specific API we are using. I just can provide you an example here. So, let's say we have a bank application and we want to transfer money. Amount of money from account A to account B. So from the attacker to, so attacker try to transfer money to victim account, and I'm sending $100. But instead of sending $100, I will send minus $100. So what do you think? What will be the outcome from this API call? Not, unfortunately. We want to have an error, but actually it's going to revert the operation and will charge the victim account and send $100 to attacker account. At the real scenario, real flow, it was recognized by the pen test teams, so it's kind of okay. So we're okay, but it's real issue. And as you can see, so the finding that only sending the minus as the attribute instead of the number, positive number, will do the opposite operation on my backend, on the backend API call. So that's the example of the business logic flaws. Some more real, I would say, examples. Citibank, ABAC vulnerabilities, it's I think 2 years ago, then the financial data of many users and many customers exposed, just because attacker tricked and tried to just to recognize the account numbers, and it was incremental numbers. Okay, so as an attacker, I have the legitimate token. For example, I'm just the user, one of the users who can use this this API, but I tried to change the account ID, and that's it. So they very soon understood that the numbers, account numbers, they are incremental. They just guess the next account IDs, and that's it. So it's one of the famous business logic or broken object level authorization of BOLA. It's A1 on the OWASP API security top 10. And it's, it's kind of the very, very basic and very simple example of that. Broken function level authorization is the more, is the interesting, also the issue about the Google+. And this also contains some thoughts also used by the CVS v3. We have the new attribute called this scope. The scope and the different scope on the CVSS v3, so it's kind of out of our discussion today, but once we have API for internal usage, and then we move it, and we allow to access this API by partners, for example. Then we change the scope of our application on our APIs. So it's also might be introduced as the scope change on the CVSS v3. And that's the example of how they try. So just a small error, small mistake by developers or maybe by architects, and they changed the scope. They allowed third-party vendors to access this API, and that's how attackers can try it 50-ton millions account exposed on this issue. So how they did it? Some points you can find it on the internet. They try to different resource name, like admin, profile, account, so /admin, /profile, /search, and try to figure out the values there. So what can they jungle the values and try to understand how our backend server expose the data. Content type, inject or remove data, so we can add more attributes, or maybe we can remove attributes totally and see what will be the output. And then they're using the answers from the errors and see how can they do the next step. Okay, so they're using, in this, they can use the AI-based solution now, actually. This one, so you have the this YouTube link, it's still available. You can see the explanation how to attack APIs. It's by, it's very famous video, so it's kind of, it's very good explanation on how to proceed and approach APIs, so what to do and how attackers work on our APIs and what they're doing. So it's very interesting. If you want, you're welcome to see that. And here's the problem on the our side, on the defender side. So the first of all, we can say that application security is still some kind of it's painful and it's not handled from the beginning. Even we have the very good secure SSDLC process, it's kind of the huge number of new APIs and changes, and we cannot test all of them all the time because we are under the agile era and we introduce the new changes all the time. Okay, and we have short releases, maybe every hour, every day. And we cannot, security team, we are not scared enough and we are outnumbered, so we cannot do that, even we have tools. And the second problem, then we also have some kind of gap on the developers' awareness. So developers, they maybe can understand something we know or well-known attacks, like XSS, SQL injection, etc., but they are lack of the awareness of the API-specific attacks. Also, it's very hard to find the good security team nowadays. And then the next problem is that once I build the new API, I know all my service or how this specific API works, but I cannot see the entire picture and end-to-end flow because it's different team with different developers, and then they can, not by purpose, introduce some backdoors or not validate something or do something in a bad way. And then we started to understand that in order to protect our APIs, we need also some kind of AI-based or machine learning-based solution. So if attackers can do that, can have AI-based solution to approach our APIs, so why we cannot use the AI solution to protect our APIs? I think it's fair enough. And then, so we wanted to define our security requirements. So first of all, we need a tool to provide us full visibility of what APIs we have, what attributes we're sending, what we're receiving. Also, we want to see attacks, real attacks, who, when, why, and where. Now try to do something with our APIs. And we also want to be able to stop those requests during the probe phase in the very early stage. So that's the high-level overview of the security requirements. But the problem here that all APIs, they are unique. Okay, so we cannot create signature here as we have for SQL injection, for example, because the business logic, every API introduces different business logic. So we should create the policy per API. So it's a huge effort, and no, the human cannot do that, actually. So we need some tool to build our policy automatically, and also to automatically run ongoing scan for changes and correct the behavior, etc., etc. So if we are looking on the what we need to do, so for now, okay, the traditional tools, we have only metadata analytics. Like we can ask what we have on the request and what the attributes we have and how and the order of attributes and what data we receive back. But we also now need to understand and do the data analysis. So it's kind of big data analysis to understand the business logic and the API logic. Okay, so something we know on the top and something we need to build on the two others. That's why we need AI solution. Okay, as I said. So first of all, why AI? Okay, so what we want to get from this tool for AI-based capabilities, high accuracy. Okay, so we want this tool to be able to understand our business logic and recognize normal behavior and build the baseline for our normal behavior. We also want this tool to be able to recognize some unexpected and 0 days. Okay, as usual, 0 days is very important. Something is not part of the normal behavior should be cached. Different patterns in the API data. So as we saw from the previous slide, there are a lot of different API types. Okay, and the SOAP-based, XML-based, JSON-based, and now some specific gRPC, whatever. So our tools should be able to understand it now in a separate, not required to understand the logic of the protocol itself. Okay, and scale. Okay, it's straightforward. We have a lot of changes. We have a lot of new APIs introduced all the time. So we need to be able to do it all the time, continuously. And knowing the right context is very important. So we need to understand and be able to connect the dots. We'll talk about it later, what is connect the dots. So we want to understand our context. So this value is actually the PII data. Or this token, we just saw this token 2 hours ago for the different requests, and we can understand that this token, specific token, used only for administrator of our application. So this kind of the deep dive knowledge of the context of our API's calls. About technical solutions, I don't want to be, to describe how we want to deploy it, but high-level overview and some options we have. So first of all, 3 main, technical or deployment solutions we saw. Filters, it's very close to code, but the problems, these filters, that if we change something, we need to recompile and redeploy. So it's very big management effort. But if you have only few APIs, maybe the filters is a good solution for you. Single gateway is the most popular for now. We set our security controls as the single gateway on our ingress traffic, and then we can understand and do our calculations and behavior solutions, etc. But I wanted also to talk about micro gateways and why we need micro gateways. Because we have also internal communication, or we call it east-west communication, between our internal services. And we want also to evaluate and understand internal traffic too. Any reason, because it might be some remote code execution, and now someone tries to run additional process on my container, for example, on my pod. Maybe because SSRF, whatever. So it's a lot of attack vectors where we will see some malicious traffic internally. We'll try to access from one service to another service inside our networking. Then I need micro gateways, and micro gateways will be able to catch and actually understand internal traffic too. It's not only for ingress connections. That's very important. 2 words about the traditional solutions like API gateways and web application firewalls. So web application firewall, it's something well known. I don't need now to explain what is WAF, okay? But the problem with WAF related to API protection is the WAF is always signature-based solution. So it's something from something we know, or well-known solutions will be cached by the WAF, so like SQL injection, etc., XSS issues. But once we're talking about context-based problems, WAF cannot help us here. DDoS and bot protection is kind of out of scope for this session. So we should have DDoS and bot protection in place. It doesn't matter. We have API protection tools, don't have API protection tools, but I want just to put it aside. And what about API gateway? So API gateway is a part of the API management system, and it's also introduced security controls. So what we have as part of the API gateways, first of all the authentication authorization management. It's great, okay? So API gateway can take our token and validate it, different types of tokens. It also can validate authorization, check permissions, check signatures, everything, okay? Great. It's very good. And also, it also can mask our internal system or internal path to the API. So from the API consumer, it might be just /users, but internal path from the API to the internal endpoint might be v1/user/number/something. And the API consumer will never see this internal path. So it's not exposed to him. So it's also something very good. What else? Outgoing communication. So we send our APIs also can consume some third parties and introduce external calls to the external API. So we want maybe to block it or to see what allowed to access to the external and what not. So it's also something that API gateway can help us. But let's back to our BOLA or mass assignment issues. Mass assignment on the left side, then as an attacker, I'm trying to add as much attribute as possible to the request payload, and I'm trying to escalate my privileges. So is admin true? Is SSO true? Admin true? Admin. As you can see, a lot of admins here, so I'm trying everything. Can API gateway stop me from doing this? What do you think? Probably not, because it's not validate the payload. It's only on the authentication and authorization path. Once I have valid token for the regular user, API gateway will not going and find those attributes inside the payload because it's kind of out of scope for API gateways. On the right side, we have the classical BOLA attack. We have user ID based on the as part of the request and also part of our header inside the cookie. And I can play, okay, and just change the user ID and see what I will receive from the API endpoint. And suddenly, as you can see, once I have the different ID on the request and on the cookie, it will take something that I passed as part of the request itself, and it will return me the kind of information of the different user. API gateway cannot catch it, this issue. What about web application firewalls? The same, because it's signature-based. The same also correct for the WAF. WAF cannot stop context-based attacks or context-based flows. It only can work on the existing or known attacks, known signatures. You can find a lot of scripts exist on the internet, and the guys tries to generate scripts to test OWASP API Security Top 10 against different WAFs, web application firewalls, some on-prem firewalls and SaaS managed firewalls, doesn't matter. We saw that it's only about 40, maximum 50% of the issues might be stopped by the web application firewalls related to API security, for API endpoints protection. What about CI/CD tools like static analysis, dynamic analysis? The same. They are all actually working on the signatures. So they can find the known issues inside the code, some kind of absence of input validation, etc., but they cannot understand the context or the logical context of our text. What can help us is the kind of the code risk management platforms. Once we have some change inside our code, they can alert us and say, okay, we have material change in your code. You changed this API, you added new API, please review it. Okay, it's great. It's the very, very shift lefty. So it works very early on the CI/CD process, and it will help us, but not 100%. Okay, so from now, I'm starting to talk about the solutions, about API protection tools. What we have, I will say as the one side of API protection, we call it positive model protection tools. So what does it mean? It's mostly work on the open API specifications. So we have documentation, we have a description of our APIs, what attributes, what's order for attributes, what it should be, and now it's the string, it's numbers, for user ID, for example, it should be only numbers in the 6, on the max of length of 6, and etc., etc. Okay, so we define it, and we provide this Swagger, for example. So here's this Swagger example as the open API specification implementation, and we provide it as the seed, okay, to our API protection tool. So API protection tool will review and run some scans of our Swagger implementation and say, okay, you have problem here and here, please correct it. And then you can take our documentation and automatically build our policies for firewalls. And then it can stop the problems from the first request, etc. So it's very effective. It's very it's very good solution. The problem here is only the open API specification. So we're talking about REST API calls. If you have something else, if you have gRPC or something else, so it's not for you. And it's also not always can stop context-based issues and provide you the big picture. Who tried to approach your APIs and when, on what services? So it's kind of out of scope here. I'm only allowed what I approved, what is my documentation. All other traffic removed, okay, automatically decline. Great, yes. So it's a good solution. We have some problems here because again, it's only for the specific open API spec. And also, if you have something legacy, not documented, APIs, it's kind of the problem. So, and you cannot use this approach, this solution. Okay. Once we are talking about AI-based components, what the things we should worry about? They're all about statistic. Okay. So we should to provide them a knowledge period and enough traffic to learn from it in order to build behavior baselines. We should do it for every API, okay, again and again. And once we have the implemented, it might take time to actually move it to the full protection type because again, we should mirror all the traffic to our central point of analysis, and only after some time, then we are learned and build our policies, we can stop actually and and prevent the bad APIs to get in. Okay, so the semi-automatic, and then we have automatic prevention architecture. So that's the flow. Okay, on alert only. Then we have some kind of semi option, and then we can move to automatic prevention architecture. So this step, it's very hard to achieve. Yes. Okay, so capabilities. what we want to have on our tool. Anomalies detection. So we want to build our normal behavior baseline. And then if something is abnormal within the anomaly, we want to explain it in the plain English, I would say. For example, this API now use inconsistency across sequence of submit account numbers and full visibility of what the values we received. If not, we have the problem because who will actually manage our API protection dashboard? In most cases, it's not security guys. Okay, so we need to explain why we stopped or why we think this is abnormal. Auto-discovery is a very important issue. So we want our AI-based tool will discover all APIs we have and provide the full data. Okay, what we have, how many access to this API, what the protocol, everything. It's also something that we need to ask from our API tools, and they can provide us. It's also very good for the building different realms for our APIs. So, for example, we can say, okay, so all the administrative API is very important for us. So I want to have the restricted policy, and others are not. Connect the dots and visibility, so that is very important. So we want to be able to understand from the different event that we have the incident. So we see, for example, some account used 2 hours ago on different server, and maybe we saw that this guy from this IP tried different probes on our server. So I'm connecting everything together, and I can say, okay, I have the incident here, and then I can stop him. Okay, I can create the attacker signature from what API, what tokens he used, etc., etc. And then I have the full picture, and that's we're talking about the connecting the dots, and I can stop him later during the probe phase. Anomalies visibility, as I said, I want to see now number of attacks from what IPs, okay, and the urgent, not urgent based on my API definition, so I can define what API is important for me specifically. And I can say, okay, I want to see and want to receive the alert of any tries on any probe on my on this specific API. Probe phase, so that's something related to the connect the dots. So why I need to stop someone during the probe phase? The big issue, these AI-based solutions, they cannot see it inline as the web application firewall, for example. So I need to understand the traffic. I'm kind of past request 1, request 2, request 3. Okay, so it's kind of, now I can recognize the signature and I will stop them. But I cannot stop someone from the first request. That's the big problem. So as early as possible, I can understand the signature and connect the dots during the probe phase. That's the key of success of the AI-based tools. So that's very important, how the algorithm developed to understand, to recognize attacks during the probe phase. Also, the important part is the content detection. So I want to have the visibility of the PII data, for example, used by my APIs, transferred as the request or transferred as the response. So I need to mark APIs, PII-based APIs, maybe secret-based APIs, etc. So again, it's the context-based, and AI tool should understand my context and say me, okay, you have this API, you are transferring PII data. In this API, you're transferring secrets. If they cannot do that, it's kind of it is the problem from our point of view. Also, nice to have some kind of security policy as a code, we call it, and be able to help our AI-based tools to take decision. So, for example, it's very, very simple. I have some API endpoints, and I get the metadata, and I say if metadata contains PII, so that's my interesting. So I'm never allowed PII data to be part of these API endpoints. So I can say, okay, if you see that, alert me or stop request, whatever. But I can provide this as a script, as a JavaScript or Python, whatever, and then tool will take it and compile inside their policy automatically. So it's very good. It's very helpful. Not all vendors provide it. Bidirectional security is a kind of the next step. So think about the SolarWinds attacks. So we want to stop outgoing connections, so from my services to consume some third-party services, and not only on the network level as the API gateway doing, but also by the context. So someone from my service tried to send PII data to the external third party. Maybe it's a problem. So it is kind of next step. We cannot see vendors now doing it, but it's very important, and we saw more and more attacks in this area, specifically for the supply chain attacks. Then we're trying to access external repositories for the additional code, etc. Just as I said, some kind of the examples of the startup in this area in API protection tools. Okay, in conclusion, so what we actually wanted to see from the API security tools, first of all, to discover all our APIs, also to provide us the visibility and be able to connect the dots on different attack, on different event, and actually connect it to the one incident from the different places, provide us the context-based recognitions, like if you have PII data, don't have PII data, so for example, this email belongs to administrator, and we saw this email only on the admin calls, and now we can see this email address suddenly coming from the different place and for different API endpoints. So it's the abnormal, and I want to receive the alert on it. And also, I want to be able to stop attacks on the early stage, on the probe stage, because again, as we saw, and as I said, that we cannot stop bad requests from the first one. Okay, we need to understand, so the tools will understand and build the signature, and then we can say, okay, so this is the attack, and they stop it, but not from the first, from the first request. Do we have time? So I think that's it from my side. If you have questions, please, we have 5 minutes.
Yes, we have time for several questions. So if you have a question, I come with a microphone.
Yeah. Hi. You mentioned that you take care about PII or GDPR relevant data. Mm-hmm. How do you do it? I mean, are you able to look into the data and discover, okay, this is like credit card number, or is it based on the metadata? Yeah. In other words, if there is like a field or something like comment, but there is a sensitive data, like credit card number is like put into this field, will you recognize this?
Tools, yes. So we have tools which can recognize it and say, okay, what you want to do with it? So you want to alert, or maybe you want to block, because this endpoint should not deal with PII data. And also from the management perspective, I want to, as I said, you want to build some kind of realm of your APIs, which are very sensitive APIs. Okay, APIs which deal with secrets on PII data and any others. Okay, so I want to build only my high sensitive APIs to be all the time tested, and all the time, I want to provide more restricted policy for them. So in order to do that, I also need to understand that they have PII data on the request. And the traditional tools cannot do that. Okay, it's only if AI-based solution can recognize it and say, okay, I just saw the credit card number here, or social ID number on this request. So let me just, please decide what you want to do.
Any more questions?
Web application firewalls have problems if the website changes, so the statistical analysis from the past isn't valid anymore. How do these solutions correspond to changing API endpoints or new API endpoints? Because they don't have statistical analysis of the new or changed API endpoint.
They're doing it all the time. It's kind of ongoing process. Discover, build the new policy, and test. Discover, but all the time.
But if the API endpoint is changed,
you will start receive alerts because it's something, and then you can correct it. You can say, okay, it's valid or not valid. If it's valid, it will automatically correct the policy.
Okay.
If not, it will just stop it.
So it also takes some human intervention to say this is valid, this is not valid.
Yes, and that's the. It's not the problem, but it's kind of the. You cannot just push it and forget it. Okay, I'm great. Okay. It's correct for the for this one. Okay, it's correct for where is it? Positive model. Positive model is exactly what you are saying. Okay, this one allowed. If it's some change or someone add new API, it's not documented, whatever. So not inside the scope, inside the documentation, just block it. And then developer will receive some kind of it doesn't work, and we'll change it.
We have time for one more question. So if there are no more questions, thank you very much. We have coffee break now. Thank you.
Thank you very much.